Good morning. This is your stats sensei, Mr. Spensey, and this is a warm-up on two proportions, and we are two sample proportions, and we're going to be doing hypothesis test. A survey given to a random sample of students at a university included a question about which of two well-known comedy shows, S or F. Some people say it's Seinfeld and Friends. Some other people say it's Simpsons and Family Guy. I have no idea. It's known that more than 4,500 students watch these shows. That sounds like the population right there. That's probably important. The students were asked the question, do you prefer S or F? So in other words, S came first here. And the responses are shown below. So in this case, we could actually set up two different p hats. We could do either 185 or 324 or 139 over 324, but we can't do both because it comes from the same sample. And I'm going to focus on S, which I believe is Seinfeld, but it could be Simpsons. In a follow-up survey, a group of randomly selected students was asked, do you prefer F or S? So they swapped the order. The first one was Seinfeld and Friends. The next one was Family Guy, Friends or Seinfeld. And the responses are shown below. And we have a smaller study here. Based on the two studies, is there evidence that the stated preference depends on the order in which the comedy shows were listed? Once again, I needed to either choose Seinfeld or Friends. I can't choose both. Since I chose Seinfeld here, I'll choose them again here. Now, I recognize that they swapped that this is Friends or Seinfeld. They still asked Friends first, then Seinfeld. So we have these two different charts. This one basically says p hat for Seinfeld is it going to equal 185 over 324. And this is going to say p hat for Seinfeld is 68 out of 156. And I just want y'all to get an idea as to the order. Now, I'm going to call this one P1, and this one I'm going to call P2. So my null hypothesis is that there's no difference. Say HO P1 equals P2. HA, it says, does it depend on the order? It doesn't ask if it was more popular or less popular. So since it depends on the order and they didn't say which order, we have to use a not equal to sign this time. It's been a while since we've had that. First thing we need is P hat C. Well, P hat C equals X1 plus X2 over N1 plus N2. Yeah. And we need to go ahead and plug in. That's our next part. So I said that we'd go 185 and 324 because I was going to focus on Seinfeld or Simpsons, whichever, and not mess with Family Guy or Friends. And this is 68 over 156. So I'm going to go ahead and add those up. 185. Oops, didn't mean to cover that up. 185 plus 68. So 253, that's my numerator. Over my denominator of 324 plus 156. My denominator is 480. So in this case, we have 253 divided by 480. And we end up with about 52.7%. 0.5270. Next, we need to address our conditions. And again, I said that P1 was going to be the first sample. So this one's going to be S or F. And this was going to be F or S, that order. All right, when we look back, they said a random sample here and a separate random sample. All right, so we have two random samples. The first one was bigger. It was a random sample of 324. And we see that right there. So random sample 324, and that was given. The next one was a random sample of 156, and that was given. The next one we need to check is that we have two independent samples. Well, they said they took one, then they took the other. So we have two independent samples. Two independent samples. And that was given. Because this is because we're working with a random samples, we have to do the N is less than 10%. So our first sample size was 324. So N equals 324. 324 times 10 is 3,240. And up here they said, oh, there's 4,500 students. So less than 4,500. That's our population that actually watch these shows. Over here, we have a sample size of 156. So N equals 156. 156 times 10 equals 1,560. And that's still less than the 4,500. So we're good to go there. Rewrite that so it's a little more clear. 4,500. All right, now we need to do the normality condition, which is different from the hypothesis test than it is for the confidence interval. For the hypothesis test, it's N1 times P hat C, and then N1 times 1 minus P hat C. And remember, we have to be greater than 10. In this case, we have 324 times, and we calculated P hat C to be 0.5270. And that equals about 185. We'll check that out real quick. 324 times 0.5270. Oops. That's not 520. That's about almost 171. All right. And as long as we're greater than 10, it's okay to do a little rounding as long as the initial number is greater than 10. If the initial number starts with a 9, we can't round. All right. 324 times 1 minus 0.5270. Excuse me, I have a bit of a cold. We end up with 153. And equals 153. And that's greater than 10. And I need to do the same thing here. That 171, I forgot to write that's greater than 10. We have to have the greater than 10. 171 is greater than 10. All right, next one. We have to do it on the other side. N1 or N2 P hat C, and then N2 times 1 minus P hat C. The P hat C is the same for both of them. N2, though, changed. Our sample size is 156. So we have 156 times P hat C is 0.2570. And that's 82 approximately. And that's definitely greater than or equal to 10. So that's good. Then we have 156 again times 1 minus 0.5270. And we get about 74. And that's also greater than 10. So our sample is large enough to use the normal approximation. So we're good to go with that. So we've met all 4 of our conditions. And we're ready to start running this test. Well, we need our formula, which is going to be P hat 1 Z equals P hat 1 minus P hat 2 all over P hat C times 1 minus P hat C over N1 plus 1 minus, or excuse me, P hat C again. The numerator doesn't change on this. It does on the confidence interval, but it does not on the hypothesis test. But instead of having, so we have P hat C and 1 minus P hat C over N1, and we have P hat C over 1 minus P hat C over N2. And so we need to go ahead and start plugging in. All right, so we have a not equal to situation. So that means we're gonna have to double whatever our answer is. So let's go ahead and look at the beginning. At the beginning, we said 185 over 324. So let's figure what that is. 185 divided by 324 is 0.5709. And I'm just going to call it 0.57 because that's close enough. Write it down as weight correctly. And then we have 68 divided by 156. And we're 0.4358. All right, and I'm just going to call that as approximately 0.44. And the reason I'm going to do that is space. And this is approximately 0.57. All right, so writing that stuff in. Actually, I have enough room to do the whole thing. So the probability that Z is greater than, I need a 2 times out there, so let me make a space for it. So 2 times the probability that Z is greater than. And the reason I know it's greater than is because the first one was bigger than the second one. Otherwise, I wouldn't know. But this is a not equal to, so we have to double it. That's why we need to double it, is because it's a not equal to. 2 times the probability Z is greater than, well, P hat 1, I said was 0.5709. P hat 2, we said was 0.4356. And then we have P hat C, which is 0.5270. And then 1 minus that over my sample size, and my initial sample was 324. That was N1 plus the same numerator, and I hope I have enough room for this, is 0.5270 and 1 minus 0.5. I'm going to call it 3 because I don't have enough room, over 156. So let's run this thing. So stat test number 6, which is 2 proportion Z test. And we have 185 chose Seinfeld out of the 324, 156, and then 68 out of the 156 chose Seinfeld when they changed the question order. And we need a not equal to. And we're going to calculate. And we get Z equals 2.77. Well, remember, since I have a 2 times, I need to have the 2 times here. So 2 times the probability that Z is greater than, and we said 2.7765. 2.7765. And that equals a p-value of 0.0054. P-value 0.0054. Alpha is 0.01. This is clearly less than, so we are going to reject the null. All right, I appreciate you watching, and I hope to see you on the next one. Hopefully this was helpful. The next one will be a confidence interval. All right, thank you.